Hi, this is John Carney, Product Engineer at Cadence, and this video is going to talk about HDI routing in OrCAD X. We'll start here with this little diagram of a cross-section of a PCB just to illustrate when it comes to HDI routing, there's different types of manufacturing rules which would dictate what kind of HDI routing you're going to do. You may have a situation like these little yellow squares represent microvias and the red blocks represents a core drilled via. And depending on the manufacturing and the price you want to pay, you're going to have situations where you'll want the microvias to be stacked coincident on top of each other. Same thing with the drill via. Or you're going to want to have your microvias stacked but some sort of space in between your microvias stacked and the drill vias. Or maybe you want your microvias to be edge to edge spacing within some spacing to your core vias. Or you may be able to have them stacked so long as the holes aren't coincidence with each other, or you may be able to do kind of whatever you want, right? So there's all sorts of different manufacturing rules that you can work out with your fabricator, and those can be set up in the constraint manager. HDI routing, really generally you want to start out with setting up the rules to drive the constraints, to drive the routing engine, and then you'll have the best results. So you first want to figure out what kind of stacking you want to have. And shown here, I'm using my control key and my mouse wheel to zoom in just like you would on a web page to zoom in on this constraint manager here. I've just got a couple examples of some different types of rules that you can do. For example, if you want to have the type of stack up where vias can all be stacked on each other, have a rule here called stacked all. And there's a rule that you can set up per layer to describe how you want the stacking. You want the stacking to be vias only, or for example, if there's another rule for stacked microvias, then you can set up for internal layers that you only allow vias and pins, or microvias to microvias, or microvias to microvias coincident only. So in other words, this is the constraint that you would set that specifies how different types of vias can be stacked on top of each other. A second rule that you're going to want to set up under same net spacing is 4 different types of nets. You can see here we have these different nets in the design, and the different nets have the different constraint sets assigned to them. So for example, like the overlap constraint or the default constraint set. If we come over here to the microvia spacing constraint set, this is where you can set up, for example, that your microvias to microvias can be spaced 0 apart, or -1 means that the pads can overlap and then the hole to hole constraint will come into play. We have more detailed app notes that we can send out that goes into the detail of this, but I just wanted to let you know that setting up the rules first will give you a much better routing experience for HDI routing. So once you have the rules set up, then you would go into add connect mode. You're going to want to put the tool into what we call this working layer mode. And what this layer mode is going to do is it's going to ask you every time you transition from one layer to another what layer you're trying to get to, and then it will punch in the desired vias that you want to use to get there. You can configure this to tell the tool what layers you're actually trying to get to while you're routing. Maybe you don't want to go to plain layers, maybe you do. And once you get that set up, then for example, if you start routing in net, as soon as you double click, it's going to ask you, okay, you're on the top layer. What layer do you want to go to? And if you choose signal 2, it's automatically going to grab the microvia that gets you to signal 2. You double click again, it'll ask you to signal 3, and then you get the via that goes to signal 3. Whereas if you were to choose bottom, based upon the rules that you have set up in the spacing, it's going to queue up the vias in order to get you from where you're at to where you told it you need to go. There it gave me the 1 to 2, 2 to 3, the 3 to 6, etc., etc. If I were to backspace all that out and start out at the beginning and double click, and instead of saying I want to go to signal 2, if you try to go right to the bottom, it then is going to queue up the first microvia, and then the spacing between this microvia and that other one is dictated by the spacing that I just showed you in the constraint manager. Then you got the second microvia, and now you have the spacing between it. So spacing between the microvia and the microvia. Now spacing between the microvia in the drill core via, then another space in between the drill via and the micro via, and then micro via to micro via spacing, and then you're out on the bottom layer that you wanted to go to. I should also show you one more thing in the constraint manager in the physical rule sets is, in addition to setting up the different ways that vias can be stacked, for each type of physical constraint set, you're going to want to provide it the list of the vias that you want it to use to get from the top to the bottom of the board. So for example, this icon's a laser via, blind buried 1 to 2, blind buried 2 to 3. Then you got a core, 6 to 7 laser, 7 to 8 laser. And then alternatively, you also have just a solid drill core via that goes all the way from the top to the bottom as an alternative via. So if you're here and go to the bottom, it's going to choose the micro via stack, or if you're any other layer, alternately just use this via. So you would set those vias up in the constraint manager, and that's what's driving that choice of which vias to use while you're routing. And then the stacking rules will come into play. For example, this net has a different set of stacking rules. So I'm going to start to route out, double click, and here if you say to go to the bottom, it just automatically stuck in the 1 to 8. However, that is a whole series of vias going all the way between them. It's still the stack 1 to 2, 2 to 3. It's effectively this whole stack just all put coincidentally on top of each other. Another example would be going to the bottom here. This is that constraint that I gave you with the negative spacing value, so it's letting the pads overlap each other, and then the DRC that's going to come into play is the hole to hole constraint instead of the pad to pad constraint, because if you've told the system my pads can overlap, you don't want to get a bunch of false DRCs. That's better, because if instead of that, if you were to, let's say, delete this and turn off the working layer mode, right? Then if you were to say you're starting at the top and you want to go to signal, let's say 3, it just punches in a 1 to 3. You don't really get the nice control over how exactly you want to get from one layer to the other layer. So if you're doing HDI routing, working layer routing mode is definitely the mode for you to use. Another thing that you're going to want to do a lot of times is once you get that stack in place, you may need to slide that stack around. So by default, the entire stack is going to slide as one unit. So if you go into the slide command, you can move that whole stack up and down. But you may want to like peel off a portion of that stack. So if you go into the slide mode and pick up that via again, you can right mouse button and choose split stack. It's then going to present you with a cross section showing you the stack that you have. And let's say you really just want to pull off these 2 micro vias. So you can click and hold your left mouse button, select the field, just kind of like you're selecting in Excel. So split stack, click and hold like you have in Excel, and then it's just going to peel off those 2 vias. And then you can, let's say I'll just push those down here, and then you got the 1 to 3 and the 3 to 8, and then you could still go into slide, split stack again, and now you have, this is the remainder. Let's say you want to just get that core via out of there. You could split that stack out. You know, I've made a mess, but I'm just demonstrating the capabilities of separating a stack of micro vias versus moving the whole micro via stack all together at once. HDI routing in OrCAD.